Alright, hi guys. So my name is Tan Nguyen from Mr. Higgins' fourth period class, AP Physics 1. So today I will be demonstrating the learning objective 5.B.5.3, which is the student is able to predict and calculate from a graphical data the energy transfer to or the work done on an object or a system from information about a force exerted on the object or system through a distance. So basically, what we need to know is when a force of F acting on an object and causes it to move a displacement d, we would know that there must be a work has been done on the object to make it move. So in order to accomplish the work on an object, there must be a force exerted on the object and it must be moving in the direction of the force. So from this, we'll know that the two factors that affect a work done on an object is force, which is measured in Newton, and distance, which is measured in meter. Therefore, we have an equation for work equals to force times the distance of the object traveled. So the SI unit for the work done by the force of F is Newton times meter, which refers to joules. So we know that one joule of work will equals to 1 Newton times 1 meter. The W also tells you that the amount of energy the force F gives to the object, which will equals to the change in kinetic energy of the object. So now let's go ahead and do a very simple practice problem that I found on the internet. So we have a man exerts a force of F horizontally into a block on a level surface, and the block is a distance d. So the question asking that we have to calculate the work done on the block by the man. So let's go ahead and draw the diagram for the problem. So here's a force distance graph that they're given within the problem in order to demonstrate the work done by the man on the block. There is also one thing that we should know about work is if the distance is zero, the work is zero even though there is a force is applied. Pushing on an immovable object such as a brick wall may tire your muscles, but there is no work done of the type we're discussing. So in physics, the idea of work is intimately tied up with the idea of motion. So if the object does not move, the force acting on the object does no work. So for this problem, in order to calculate the work, we need to find the area under the curve, which is this part of the graph. So looking at the graph, we'll see that we have a rectangular shape. So the area of the rectangle is equals to the length times the width. So we got that the area is equals to 60 Newton times 4 meters. So we get 240 Newton times meter. So from this we can conclude that the man has done a work of 240 joules on the block in order to move it 4 meters away from the original point.